Imagine a bright 14-pound bowling ball floating in total silence in the vacuum of orbit, exactly 400 miles above Earth. What happens to this dense sphere of plastic and resin the moment we let it go? Out here, the ball appears weightless and still, but an invisible tether remains firmly connected to it, Earth's gravity. Letting go opens a massive cosmic energy ledger. Every mile the ball plummets becomes a line item that gravity must eventually balance. At this altitude, the ball holds a vast amount of gravitational potential energy. This is a form of stored energy an object possesses based entirely on its position in a gravitational field. The law of conservation of energy dictates that this potential cannot simply vanish as the ball falls. It has to change form. This ledger shows the conversion in real time. As gravity pulls the ball down, the potential energy bar shrinks, transforming directly into kinetic energy, the energy of motion. Because the vacuum of space provides no air resistance, this acceleration is mathematically pure and perfectly efficient. This falling motion is essentially the reverse of escape velocity. Escape velocity is the speed, roughly 11.2 kilometers per second, required for an object to break free from Earth's gravity. If you dropped an object from an infinite distance, it would reach that exact staggering speed by the time it reached Earth's surface. The vacuum environment exists to forge pure speed, maximizing the ball's kinetic energy before it ever hits resistance. The environment shifts abruptly as the falling ball slams into the densely packed molecules of the upper atmosphere. At thousands of miles per hour, the ball is moving too fast for the air to simply flow out of the way. It hits the gas like a wall. Compressing the gas directly in front of the sphere generates immense friction and extreme temperatures, creating a violent plasma shockwave. This is the same stress that causes smaller meteors to completely vaporize. You can see the result in the melted, scarred surface of this iron meteorite. Because a bowling ball is a large, dense object, its core survives this fiery stage, even as the outer plastic shell begins to melt away. This brings us to terminal velocity, the exact moment the upward force of atmospheric drag grows to perfectly match the downward pull of gravity. The ball stops accelerating, the plasma trail vanishes, and the charred sphere enters a steady freefall. Terminal velocity acts as the atmosphere's natural braking system. It sets the final speed limit before the ball hits the ground. The charred remains of the ball plummet the final few hundred feet towards solid Earth. When it hits, it won't bounce, it will shatter. This is what physicists call an inelastic collision. These occur when a very small mass strikes a vastly larger one, and the kinetic energy is not conserved in the form of motion. Because the Earth is essentially an immovable wall, it absorbs all of the ball's downward momentum without shifting a fraction of a millimeter, but almost none of the ball's kinetic energy transfers to the Earth. Instead, that energy is trapped within the ball itself. Since energy cannot be destroyed, that trapped kinetic energy transforms instantly. It turns into intense heat and catastrophic structural failure. The ball violently shatters, blowing a smoking crater into the ground. This localized destruction is a small-scale version of the Late Heavy Bombardment, a period 4 billion years ago when massive debris constantly reshaped the surfaces of the young planets. This drop is more than a thought experiment. It is a demonstration of the same forces, gravity, kinetic energy, and inelastic collisions, that physically forged the Earth.